Today we're going to continue on with our Ender 3 Klipper series. We're going to take a look at enabling auto bed leveling. Hello everyone, Chris here, and yes, we are continuing on with our Ender 3 Klipper series. One of the features in 3D printing that I get the most questions on, and everyone seems to want to give it a try, is auto bed leveling. Every version or flavor of firmware that I try does it just a little bit differently, and Klipper is no exception. There are quite a few things you have to do to get it set up in Klipper, but that's what we're going to do today. We're going to walk through all those steps, and we're going to talk about a couple of features that you can use inside of Klipper, a few things that do it differently than other firmwares do. Also, we're using the BL Touch sensor for this setup. I've already done the video on how to set up the BL Touch on the Ender 3 V2. We did use Marlin, but it's pretty straightforward. If you need help with that, take a look at the video in the description. So let's take a look at the hardware real quick, and then we'll move on to getting everything configured and hopefully have a nice bed mesh that we can use on our Ender 3 V2. Let's go. So just to pick up where we left off, we did install that BL Touch during the Marlin series. You can see it here. This is the BL Touch kit for the Ender 3 that Creality puts out, but this is an authentic BL Touch sensor. So it's going to work out just fine. Now, in the last video for Klipper, I did an install with the N-stop. So we want to go ahead and remove this Z N-stop, because after we get the BL Touch set up, we will no longer need it. So we'll just remove that. And again from that BL Touch video, we are using the Creality 4.2.2 board, and the BL Touch probe pins are right here. That's where our BL Touch is plugged in. So we'll need to update our Printer.cfg file to reflect the changes that we need to make that BL Touch work. So we'll head into Printer.cfg. And you can make these updates anywhere, but for something like a BL Touch, since we're doing away with the Z N-stop, I'm just going to put them underneath this Stepper Z section right here. It just seems to flow a little better that way. Now, the first hurdle that I always run into with Klipper is, what pins do you actually need to use? What are those pins on the board called? And with the Creality boards, that can be pretty challenging because they don't have the best information as far as schematics and pinouts go for their main boards. A lot of other companies do. But enter our smart community members from the internets. There is a schematic out there for this Ender 4.2.2 as well as the 2.7 board. But somebody who did a whole lot of work mapping this out so that you were able to get the pin numbers that are used on this MCU. These are just GPIO pins, remember? General pins for input-output. And this diagram is very small, but if we zoom in, the bottom right section right here, that's that BL Touch port that I just showed you where our probe was plugged in. And if you follow the schematic, there should be a pin for the servo and a pin that assumes a Z N-stop pin to let you know when you've homed. So we've got our servo pin at PB0 on the MCU, and then our minimum pin at PB1. And those numbers, the MCU pin numbers, are what you would use in your Klipper config file. I've also had good luck referencing the Marlin pin files because they've kind of already done some of this work for you. So you can go to the Marlin GitHub, get their file, and in turn use those numbers in Klipper as well. Most of the time you'll find a schematic for your board if it's a more common board. So back to our Printer.cfg, now we have the pin information that we need to set up that BL Touch. So the first change that you'll want to make is to tell the configuration that we're no longer using a Z-min N-stop. We're not using a switch. So in the Stepper Z section, in my configuration at least, N-stop pin is currently PA7. We'll want to change that to a probe virtual N-stop. So instead of that pin assignment, we will type in probe :Z_virtual _N-stop. And Klipper will know what that is. And then for N-stop position, since it's not an actual N-stop anymore, we can just put a # in front of that to comment it out. So now it knows to read the BL Touch when we're homing. Next, we're going to start a new section for our BL Touch. So in brackets, we're just going to do BL Touch. And then we're going to enter our sensor pin, sensor underscore pin, and put your colon on there. And that's going to have a caret because we want to enable the pull-up resistor. Remember, we saw that before. And then pin PB1 from that diagram I showed you. This is the pin that will act like your end stop. So the white wire on most of the BL Touch wire looms. The next pin is for the servo pin, so we can trigger the servo. That would be the control pin. So control underscore pin colon PB0, just like we saw in the diagram. Thanks to whoever created that diagram, by the way. Then we need to set our probe offsets. Where is that probe located on the printer? Fortunately, Klipper treats the offsets just like Marlin does. So if you're to the left of the probe, it's going to be a negative value. If you're to the front, it's going to be negative. Positive in the back or the right. So that goes 1 for 1 for us. It's really easy to enter. You can just use your ruler to measure from the tip of the nozzle to the tip of the probe. It doesn't have to be super accurate, but you remember from our last video, we have our X underscore offset, colon space negative 42, because we're to the left. And then our Y underscore offset, negative 10. And then our Z offset, we're going to have to calibrate that. You could probably use the value you have in Marlin today if you're converting over, but we want to show those steps. So let's just set it to 0 for now. So that's all there is to set up the BL Touch, but there's a lot more to this. The next section, we need to do some Z-safe homing. Remember, we have to home in the center of the bed because if we try to home on the edge, it's going to crash. To do that in Klipper, we'll just do brackets, safe space Z underscore home. And then we need a homing position. I just like to do the center. And for Z-safe home, the center is the center of the bed, whereas the nozzle is located, not the probe. So it's going to put the nozzle in the center of the bed. But that's okay to home with, no big deal. So we'll do home underscore XY underscore position. And we'll do colon. And for our XY position, the bed on these is actually around 235, 235. So we'll just split the difference to get in the center. 117.5, comma 117.5. And then the next line, you can set how much the Z raises before it goes to the home position. That's just a safe thing to do. I would go ahead and set this. In fact, it might be mandatory, but do Z underscore hop, colon, space, and then that amount. 10 millimeters should be good enough. And then after that, what's the hop speed? How fast do you want it to raise? Just do Z underscore hop underscore speed, colon, and let's just set it to 5. Remember, anything that you need to know about these parameters is in the reference. You can flip back to the Klipper reference, see anything you want about these processes and what these parameters mean. There's a great guide on just BL Touch out here. This is just a line item in the master document. This tells you everything you need to know about it. Next, we need to create our bed mesh. This is what points will the probe touch when it's trying to figure out how level the bed might be. Just brackets, bed underscore mesh. We can set the speed. How fast does it go when it's building this mesh? Speed, let's set it to 120. I believe all these speed increments are millimeters a minute. Then you can set how far the Z will move when it's moving from point to point. That would be horizontal underscore move underscore Z. And let's just set that one to 5. Keep it kind of slow. Then we need to set our mesh minimums and mesh maximums. This is how far in X and Y that the probe can travel. So we need to get to a certain area before it starts probing, and we need to stay out of certain areas. So for mesh min, mesh underscore min, colon, I'm going to set mine to X15 and then Y15. Now be careful here, because the probe and nozzle points for bed mesh aren't the same as they are for homing. So when you're setting your mesh up, rather than home, I told you home, we set it to the middle, that's where the nozzle is going to be. For this mesh, let's just say I set it to 15. That's 15 from the end stop and 15 from the end stop where the probe is. And then again on maximum, the probe is quite a bit in. And you have to consider what your offset settings are as well. So you have to be kind of conservative where the printer is going to be as far as where the probe is concerned. So set it in quite a bit if you have this type of configuration. And you can always play around with those mesh mins and maximums. Just run it and see what it does. It's going to throw an error and tell you that it can't get to that spot if the math doesn't work out right. But I tested it a few times, and my mesh underscore max for this printer, it's going to be 188 in the X. Remember, because that probe is so far to the left. And then 191 in the Y. That will enable you to get, mostly around the bed, a good enough reading to get what we need to do done. Then we need to decide how many points we would like to probe. The more you have, the more accurate the mesh is going to be, but it does take quite a while. So we want to do probe underscore count. And then for X, let's just say 5, and then Y 5, for a total of 25 points. Then you can pick which algorithm you'd like to use. So we'll do algorithm, and we're going to do bicubic. This is close to something like bilinear in Marlin. If you'd like to check out the different algorithms, remember, they're in the Klipper documentation. Use whichever one you like, or you think's interesting. And then we're going to set fade start, fade underscore start, to 1. This is where it's going to start to fade out the effects of the bed mesh leveling. Remember, we're just trying to compensate the level of the bed. As it goes up, it can fade it off and be a little less necessary. It's going to move it in really small increments, so you're not going to be able to notice that. So we'll start bleeding it off at about 1 millimeter, and then we'll do fade end. When do we want it to complete the fade out? Let's say 10 millimeters. And then we want our fade target to be 0. You can think of that fade target as an additional offset after the fade has completed, after you've already pulled out any of that compensation that the bed mesh leveling has added. Now, in a perfect world, 0 should be what you're aiming for, but it can be different depending on the specifications that you have for your print bed. You might need additional offset. Check out the documentation for all the interesting info about how all that works, but most printers are going to be shooting for 0. And this should be all we have to add to get our configuration working with our BL Touch. So let's go ahead and save and restart. And it looks like I messed up some of the syntax. This is where you're going to want to look if you've messed up your configuration file. I missed an underscore. So let's go correct that really quick. Here it is. Should be good. So we'll try that again. Now we're good to go. So the first thing we're going to want to do is make sure that our probe is working to home the printer. So I'm just going to do home all, because I'm pretty confident in my configuration. X and Y work just fine. We didn't make any changes there. You see we're moving to the center of the bed. As far as the nozzle is concerned, the probe did deploy. We're going to take 1 and 2 touches. Now we're homed. So the first part worked. Now we want to try to build a bed mesh. So I'm going to go ahead and heat the bed up to 60 to try to get a good representation of what the bed would be like while printing. Once we're up to temp, we can head over to height map. You can do this command line if you'd like. You might see something bed mesh calibrate. It's the same thing that we're going to do here from height map. But we need to make sure the printer is homed. And after that, we can run the calibrate. And here you can save your mesh, whatever name you'd like. Let's just call this one video, so I remember which one we did for this video. And then we'll hit calibrate. And like any other auto bed leveling procedure, it's going to go around to the bed to all the points that you specified and take a measurement. Now there is one thing that I purposely left out that you might run into, and we're going to see that here in just a moment, because I did alter the bed just a little bit so that we can see this. When we get to that point right there, the leveling stops. And we got an error down here in the corner, but we can take a look at that again in the console. No trigger on probe after full movement. That's because the printer thinks the end stop is at 0 and it can't go into the negative to get the point that it needs. And I think a lot of people stumble on this. It's real easy to fix it. You just have to remember to correct it when you're done. We just have to trick the printer into thinking the end stop is lower so it can go lower to get that point. So we'll go into Machine, alter our Printer.cfg, and under our Z stepper, we're going to do position underscore min, and let's just give it a -3. Our bed shouldn't be more than 3 millimeters out. This should be able to let us get low enough to do that calibration. And we'll save and restart. And then we can start our calibration one more time. Notice this time we safely made it past our low point, and we can continue on. When we're done calibrating, we can take that line item out. And when we're done, we get our mesh. Now you can do several things here. You can turn off the wire mesh, you can get a flat mesh representation, probed points, all that good stuff, and you can also spin it around. You can see we've got some low points, but there's not a lot of really wild colors here. Remember, this is 0.2. And then down here, we've got 0.2. So it might look kind of drastic, but the mesh really isn't that far off. All around, it looks like the left side of the printer is a little higher than the right. And you could fix that with the bed knobs if you'd like. You could really tune this in. And that's the first thing that I'd probably do. Try to bring some of those bed knobs down, level this out even more. But this isn't anything out of the scope for the bed mesh to be able to compensate for. No problems there. And then once you're happy with your mesh, I just go back to the console and say save underscore config. That will save it to your Printer.cfg file for later use. That does automatically restart Klipper, but then if you go into Machine, Printer.cfg, down at the bottom, there's your mesh. And you can also take this and put it in a visualizer if you'd like to fine-tune it somewhere else. So from here, this is pretty much just like any other auto bed leveling in any other firmware. We use the probe to build a mesh, it should be able to compensate for that. Now there are other things that you can do. In Klipper and something a lot like it in RepRap, there's screw tilt calibration. That's really intended for multiple lead screw printers that use it on Z, so you can go around and calibrate at all of those screw points and it will tilt the bed for you before you even create your mesh. Now in Klipper, there is a process that you can use that same thing with a manually leveled bed like on an Ender 3. You can measure each one of the spots where the wheel is. It will tell you how far to turn it to level the bed out before you take your mesh. Now I would rather go over that with a multiple lead screw machine because I think it is pretty interesting to watch it do that. So we're going to skip that for this video. If it's something you'd like to see on the Ender 3, we can definitely run through it. But we still do have a little bit of work to do. Klipper has a process to help you set your Z offset. And currently ours is still set to 0. So let's walk through that. And Klipper has a probe calibrate command that will help us set that offset. So again, I'm going to heat up to 60C and we're going to home the machine so we can get the nozzle into the center of the bed. If you don't have Z-safe homing, you can just move it to the center of the bed. Once at home, we're just going to head over to the console and we'll run the command probe underscore calibrate. It's going to take a probe and then it's going to move the nozzle over to where that spot was probed by using the offset. Now you want to make sure that your nozzle is clean before you do this. You don't want any filament skewing the results. Then we're just going to get out our trusty paper to do the paper test. Now, a lot of folks will tell you you don't want the bed at printing temperature when you're doing these measurements. You definitely don't want the nozzle at print temp, because that can ooze filament and cause problems. But I've found that the bed up to a temp, or at least somewhat medium temp, PLA for 60, I found I get good results. So try both cold or up to temp, see which one works better for you. This is just how I do it effectively. But during this probe calibrate, Klipper has a mechanism. We can do test Z, space Z equals, and then how much you'd like to move that nozzle. So we want to come down, so we'll do -1. This is just a controlled way to get us down to that paper. So you can see we move down 1. Well, let's do that command again. And we'll decrease increments until we get close to the paper. Now, once we're down where we have some friction on the nozzle, we'll go back to Klipper. You can see all the increments I used. I just started out with -1 millimeter, then dropped it down to 0.1. You can go back up. Remember, negative is down, positive is up. But just until it starts to grab the paper. And remember that minimum position setting that we did before, I set it to 3. If your offset is greater than 3, it's going to throw an error. So you might need to bump that up. I did have to go back and set mine to 5. So I was able to go past that 3. But we're currently setting at a -3.107. So when you've started to grab that paper and you're happy with it, all you have to do is enter accept. And that will end the calibration and save your setting. And we can just run a save config one more time to save it to our Printer.cfg. And you will notice that the Z offset is a positive value. That's something coming from Marlin that's a little bit odd, because in Marlin it was always negative. Just keep that in mind. When you're setting the offset, you're going to be in the negative value. When you set the offset in your configuration, then that's going to turn to the positive. You can see it all the way down at the bottom here, Z offset. And you can update it up top if you'd like, but it's just as safe right here. Now that we have built our mesh, we've set our probe offset, we want to be able to use that mesh while we're printing. And you have a couple of options here. You either need to pull a saved mesh, or go ahead and rebuild that mesh every time you print. So if you want to rebuild it on every print, I would go into Machine, go into Marlin.cfg, and then on your Start Print macro, like we set up in the last video, right after you get your bed up to temp, again, that's me, I would go ahead and put in bed_mesh_calibrate. This is the exact same command like we did before on the height map screen. It's the same as pushing that button. So it's going to go around, build the mesh, and then it will use that mesh for this print. But it does it every time, and that can take up a lot of time. Most printers, you probably don't need to rebuild it every time. So I'm not going to go this route. I'm just going to pull the mesh that we already built. You can see from the height map screen that nothing has been set. It's because we haven't loaded, because we've already rebooted the printer once. But we have a couple of meshes over here. You can just go ahead and load them, but you can also load those with a command. So if you went to console and you did bed_mesh_profile space load equals, and then the mesh's name. This is case sensitive. The mesh names are in your Printer.cfg file or that height map screen, but we're just going to load the one called video. This is the first one we did. That will load that mesh. You can go back to height map. There's the mesh we created. Now to get that to load for every print, again, put that in the start macro that we created. So machine, Mainsail.cfg, And you can load it at any time. But I'll just load it in the same spot after the bed reaches temperature. Again, bed underscore mesh underscore profile space load equals video. And that's going to be different depending on what you call your mesh. That's going to load it before every print, just to make sure that it's active, so we can save and restart. And just to prove that our updates are going to work, let's go ahead and go to height map, and let's clear this. And then we'll go to G-code and start our benchy print. Once the bed is up to 60, it should have ran that bed mesh load. You can go over to height map and make sure it's the correct mesh. And it's there, so we loaded successfully. And like any good firmware, if you need to adjust your first layer on the fly, you have these settings here on the dashboard. You can raise and lower as you wish. These are very fine amounts, so you should be able to get it dialed in just perfect. Just be mindful which button you're hitting. The greatest amount here is 50 micron, remember. And after the skirt was completed, it looks like the first layer is going down pretty well. Remember, you can always adjust it on the fly. And there we go, we have successfully enabled auto bed leveling with our BL Touch sensor on our Ender 3 V2 running Klipper firmware. Now again, it's just like regular auto bed leveling in other firmwares, it's just a few different steps to get it up and running on Klipper. And as I said before, there's a few other tricky things involving leveling that Klipper can do. If we'd like to take a look at those, we can do that in future videos. But that will be it for today. I hope you found this helpful. I'll see you soon on the next one.